In this presentation, I will introduce you to the concepts of doubly linked list. So let's get started. Let's see the definition of doubly linked list. A doubly linked list is different from a singly linked list in a way that each node has an extra pointer that points to the previous node, together with the next pointer and data similar to the singly linked list. So what we have, the difference between a doubly linked list and a singly linked list is that here, in case of doubly linked list, each node has an extra pointer that points to the previous node. So this is an example which shows a doubly linked list. And here is one such node of doubly linked list which has a previous part as well as the next part. Okay. So next pointer points to the next node of the list and prev pointer points to the previous node of the list. Okay. So this is the difference we got in case of doubly linked list. So actually we got the ability to move backwards. Isn't that so? In case of singly linked list, of course, once we move forward, we won't be able to move backwards. But in case of doubly linked list, we have that capability to move backwards. Seems interesting, but since childhood, I have seen a node with just one pointer and data. How to create a node with data and two pointers? Add just one more field to the self-referential structure and it's done. So here is how a singly linked list self-referential structure looks like. Here we have a struct node, of course. The struct node has been declared where we have a data part as well as the link part. But in case of doubly linked list, we will have two pointers and one data part. One pointer is prev and the other pointer is next. So these are just the names. Obviously you can choose your names, but these names make sense, right? So this is how a self-referential structure of a doubly linked list looks like. Now let's just see how to create a node of the doubly linked list. Obviously this is the way we would declare self-referential structure for a node, and inside the main function, first, I will create a pointer that is head pointer, which must point to some node. And for this purpose, of course, some memory has to be allocated, and that too dynamically using malloc function. And here inside malloc function, we have to pass the size of struct node so that we would be able to create memory for this particular structure. After this is how it looks like. Obviously, the memory has been allocated. We got some address, and this address is stored within this head pointer. And then we can simply put null in the prev part. Data part can be replaced by 10. It could be any other value. And next part can also be replaced by null. This is how a node of doubly linked list can be created. Okay friends, this is it for now. Thank you for watching this presentation.